Okay, welcome viewers. Today just I'm going to discuss about estimation, specifically estimation for decision making, confidence interval in business and management. You know why estimation? Let me start from this one. Why estimation is matter in management? Managers rarely have full data. They rely on samples. You know, every manager needs information. To get information, the managers must collect data and process that data. So, if possible, it's interesting to have data from all sources, from all respondents, or from all records, but it's time consuming, costly and destructive. So managers rely on sample. So when they do have sample, they have to estimate the population result, so that this estimation helps them in forecasting sales. It may help them budgeting, planning. It may help them quality control. It may help them customer satisfaction analysis. In general, it helps reduce uncertainty in decision making. So managers must use estimation or apply estimation for their decision. What is estimation? Using sample data to estimate the population value. This process, we have to estimate maybe the population mean or the population proportion. To estimate, first we have to have point estimate. That is single value that we can get from the sample data or sample information, and then based on that we have to estimate the interval estimate. So here we have to understand two types of estimates: point estimate and interval estimate. The point estimate is the single value, while the interval estimate is the range of the possible value. What we estimate is the confidence interval. So the confidence interval gives a range of the likely value. Managers interpret it as we are fairly confident that true value lie in this range. So using the value from the sample, or statistics, sample statistics, using the sample statistic, managers want to say something about the population, that we are fairly confident that real value lie in this range, so that when they estimate, they should have the point estimate, that is estimate plus the margin of error, or the estimate minus the margin of error, so that the estimate, the parameter, the population parameter result is in between the estimate, the point estimate plus or minus the margin of error. Let us see with the example. We do have three cases. Let me start from the first case. Here, the first case, when the sample size is greater than or equal to 30 and the standard deviation is known. the population standard deviation is known. In this case, the large data is available, population variability is known from historical data, so we can apply this formula. X bar, that is the mean of the sample, plus or minus margin of error, that means V alpha over 2 times standard deviation divided by the square root of n. By applying this formula, we can estimate the interval. For example, in case of production quality, a factory track product weight, mean weight is 50 units, known variability is standard deviation 10, sample size is 36, with 95 confidence level. What is the interval? So here 95 confidence level, we can check this because n is greater than 30. We have to apply the normal distribution table. From the normal distribution table, the alpha level 0.5 or 95 confidence interval level, which is its alpha level is 0.05. From the z table we will get 1.96. This score 1.96. So based on the formula, confidence interval, which is equal to x bar plus or minus the alpha level, the d value I mean, multiplied by the standard error, standard deviation over square root of n. So here our sample mean is 50, so confidence interval, which is equal to 15 plus or minus 1.96 for 95 confidence level, multiplied by 10 over the square root of 36. So here the margin of error, that means the z value of 95 confidence level 1.96 multiplied by 10 over the square root of 36, that is margin of error, is its product is 3.27. So here we have to add and subtract 3.27 margin of error, so we will get the confidence interval. So when we deduct from 50 3.6, we will get 46.73. When we add this 3.7 on 50, we will get 53.7. So the confidence interval is in between this. What we mean? We mean that with 95 confident, the true average product weight is in between 46.73 and 53.27 unit. When we come to case 2, when n or sample size is greater than or equal to 30 and the standard deviation is unknown, here the difference is only substituting the population standard deviation with sample standard deviation. So here the same to the previous example. So x bar, which is sample mean plus or minus the standard, I mean the z score of the alpha over 2 times standard deviation divided by square root of n. So here is an example on customer spending. The average spend is 80 birr. The sample standard deviation is 12. The sample size is 49. With 95 confidence level, what is the interval? Here the same to the previous one, 95 confidence level. Its Z score is equal to 1.96. So here immediately we have to insert what we have got from the statement. So the mean is 80, and 80 plus or minus 1.96 times 12 over the square root of 49. So here the two, the Z value, the Z score value 1.96 and 12 over the square root of 49 is margin of error. So the margin of error, the product of the two is 3.35. So the confidence interval is equal to 80 plus or minus 3.35. So when we deduct 3.35 from 80, we will get 76.65. Less than or equal to mean, less than or equal to when we add 3.35 on 80. So the interpretation is 95 confidence that true value of customer spending is between 76.65 bar and 83.35 bar. This is the case. This is the example for the case 2. When we go to the case 3, it is for small size. That is for when n is less than 30 and the standard deviation is unknown. The difference here is, here what we have to apply is not normal distribution, rather t distribution or t students distribution. So here the formula is almost the same except this t value. So x bar plus or minus t alpha over 2 times standard deviation over square root of n is the formula to estimate the population parameter. So the example is as follows. It's on employees productivity. Managers study employees productivity using a small sample. Sample mean, which is equal to 100 units. Sample standard deviation 15. Sample size 25. Confidence level 95. Here, to estimate t value, unlike the previous one, we have to get the t value based on degree of freedom and confidence level. So based on this, the degree of freedom n minus 1, that is from sample size 25, we have to deduct 1 and we get degree of freedom 24. This 24. So here the value from the table we can check, t value is 2.064. So here now we directly insert the values. So the sample mean is 100 plus or minus the t value is 2.064 times 15 over the square root of 25. So this t value and the standard error 15 over 25 is the margin of error. So its product is 6.192. So we have to add and deduct this 6.192 on 100. So when we deduct from 100, we will get 93.81. When we add, we get 106.19. So the confidence interval is in between this. Its interpretation is the manager with 95 confidence that the true average employee productivity is lies between this value, that is 83.81 and 106.19 units. Okay, we have to say something about takeaways for this decision. Estimation help make data-driven decision. Always consider the sample size and the data reliability. The other is the confidence interval show risk and uncertainty. So the narrower the interval, the more precise the estimate. This is all about today's presentation. Thank you for attending. This is all about today's presentation. Thank you, viewers.